All right, let's try to do a more challenging questions. Um, you're asked to show that something is equal to something, something on the left is equal to something on the right. So what we can do is we will start either from the left hand side or the right hand side. If you start with the left hand side and then you'll do some manipulations and finally you'll get the answer that is shown on the answers that you're supposed to get on your right hand side. Or if you do it the other way, that means you start with the right hand side and then you do some manipulations and finally the answer you're get supposed to get would be the answer that it's given on the left hand side. Um, right. I think judging from these questions, I think we will start with the left hand side. Let's write down some of the rules that we have learned so far. Right, we see that there's a radical sign. This is a radical sign. This one is called radical sign. Right, so one of the rules that involve radical sign would be this one here. That will gives you in index form. Right, on the left hand side is a radical form. In index form will be a to the power of m over n. Right. Now one way to remember this is that if you look at the right hand side, right, n is the denominator. So your denominator is actually outside your radical sign. Then m is your numerator. So your numerator is inside, okay, inside the radical sign. So I suppose we may need to use that. The other one would be a to the power of m, the usual one. This is really a very popular one. And also this. Okay, right. So let's start with the left hand side. All right, the moral of the story is we will always try to work out whatever that's inside the bracket. All right, work out whatever that's inside the bracket. So in this case here, um, 4 to the power of m, all right, 4 to the power of m, you can express it as 2, 4, you can express 4 as 2 squared, right? Then bracket to the power of m, so that gives you to the power of 2m. So we are using this rule here, okay? So that gives us 2 to the power of 2m. All right, so that's the first moral story. Second moral story is that we work, we work from inside out. So after we settle the brackets already, we settle things that's inside the radical sign. Okay, you settle, right, inside out. And that will give us, okay, bracket means times, so that gives us 2 to the power 1. 2 means 2 to the power 1, right? So change the bracket to times, that means 2 to the power 1 times 2 to the power 2m. Right, and this one here, we can apply this rule. And that will give us 2 to the power of 1 plus 2m, but you can write it as 2m plus 1. Why want to write it as 2m plus 1? Because can you see what you're supposed to prove on the right hand side? They express it as 2m plus 1 rather than 1 plus 2m, right? Okay, so we have dealt, we have do whatever we can, right, inside the bracket, inside the radical sign. Then the next thing, of course, is to express it into index form, because whatever you ask to solve, whatever you ask to show, right, this guy here is in index form, So what happens is that you're given something that's in radical form. This is called radical form. And then you just have to express it in index form. All right. And this, we can make use of this rule here. This guy. All right. So that will give us 2. And then there'll be a fraction, right? There'll be a fraction. So what is the denominator of the fraction? The denominator will be the one that's outside the radical sign. Remember what I said, that's you are at the bottom. Denominator is at the bottom. So when you're at the bottom, you're outside the radical sign. And then the numerator will be the one that's inside the radical sign. And here we are. It's exactly what we need to show. So equals to right hand side, happiness, and bracket shown. Yeah. Okay. Smiling face. Right. All right. We have good success solving part 1. Now let's proceed to solving part 2. Now the keywords here is the word hence. So what does this word hence means to you? Actually, it's nothing really fantastic. The word hence means you have to make use of the answer that you have obtained in part 1. Alright, so basically what is it that you have obtained in part 1? We have managed to show that this guy that I've underlined is equals to the guy that I've circled. Right, so what's the implication here? The implication here is I can just replace this guy that I've underlined twice with the one that I've circled. Right, so 2 to the power of 2m plus 1 over n is equals to 8. Right, do you remember doing something like that in question 7c? Something left equals to something right. What do we do? Yes, we can express 8 as 2 to the power 3. Alright, so we will have an equation where you have base 2 on both sides, and hence the power must be the same. So we have 2m plus 1 over n equals to 3. You can write 3 as 3 over 1. So we can do a cross multiplication, a cross shortcut. Or you can just multiply by n on both sides, alright, times n over 1 times n over 1 on both sides. Then you end up getting 2m plus 1 on the left hand side, and on the right hand side will be just 3n, because that will be 3n over 1, that gives you 3n. Alright, most likely we're going to use substitution method, because it's supposed to solve the simultaneous equation, meaning there are 2 equations, and to have 2 equations you either solve it using simultaneous or elimination. Right, I think we can just, right, never mind, we can just leave it as it is. Let's see if it's easier to use elimination. So we're going to call that equation 1. Right, so we're going to work now on the second equation, and that is 27 to the power m over 9 to the power n plus 1 equals to 81. That's right, 81 is 81 over 1. Okay, so from there you can see that the smallest base possible is base 3. So 27 is 3 to the power 3, and that gives you 3 to the power 3m. 9 is 3 to the power 2, then bracket to the power n plus 1. 81 is 3 to the power 4. Alright. Okay, just a reminder, when you take 2 times n, remember to take 2 times 1 as well. So that will give us 3 to the power 3m. Let's use the same color. Give us 3 to the power 3m over 3 to the power of 2n plus 2. Alright. Okay. And that gives us to one very important rule that we have to apply here, right? Okay, this is a very important rule that we have to use here. What is the important rule that we have used here? Recall that if you have a to the power m divided by a to the power n, you can write it as a to the power m over a to the power n, and that gives us a to the power m minus n. Okay, right. So let's continue. So that gives us 3 to the power 3m minus bracket, make sure you bracket it, 2m plus 2 equals to, oh, I think there's no need to write 3 to the power 4 as 3 to the power 4 over 1. 3 to the power 4 will do, right? Okay, so let's continue. So that will give us 3 to the power 3m minus 2n, and beware, plus times negative is negative, so minus 2, 3 to the power 4, and since we have base 3 on both sides, therefore the power must be the same. And if we simplify further, we get a second equation. This is 3m minus 2n equals to 6. We're going to call that equation 2. Right. So in this case here, I would prefer to use elimination method. Right, if you use substitution method, it's going to be quite tedious. Because if you look at equation 1, if you're going to make n the subject, it's going to be 2m plus 1 over 3. And if you're going to make m the subject, is 3n minus 1 divided by 2. I think it's easier to do used elimination method. So we should continue at the next slide. Right, I'm going to eliminate m, which means I'm going to take equations 1 and multiply by 3. Right, so 2m times 3 will give me 6m. 1 times 3 will be 3. 3n times 3 will be 9n. I'm going to call this equation 3. And then for equation 2, I'm going to multiply it by 2. So I would have 3m times 2, 6m, 2n times 2, 4n, 6 times 2, 12, and I'm going to call it equation 4. Alright, so I'm going to do now is to take equation 3 minus equation 4, which means 6m plus 3 minus bracket, make sure the bracket must be there, 6m minus 4n. Then on the right hand side will be 9n minus 12. Right, let's continue. So I would have 6m plus 3 minus 6m, and beware, minus times minus is a positive for n equals to 9n minus 12. So 6m minus 6m, our dear 6m will be gone, bye-bye. And then I will have 4n plus 3 equals to 9n minus 12. Let's put all our n's on the left hand side. All our n's, oh my god, okay. That will give me negative 12, and the numbers on the right hand side. So negative 5n is equals to negative 15. N will be negative 15 divided by negative 5. That gives us 3. Happiness. We got the answer for 3. Answer for n. Alright, but our mission is not accomplished yet. We still have to find the values for m. So what do? We substitute n equals to 3 into equation 1. So 2m plus 1 is equals to 3 times 3. That gives us 9. 2m is equals to 9 minus 1, 8. M will be 8 divided by 2, 4. Alright, happiness. So we found the answer for n and m. N and m? Oh, okay, n and m. That's 3 and 4. Great. Good job. So time to challenge yourself again. What is the questions? And you should get. Alright, believe in yourself and you'll be halfway there. Good luck. You can do it.